Sorry. Okay, I think I will see in the book. What page is it? Okay, I see. Good. So, 30. I disappear. So I okay. So what's your confusion in this? Can you open your mic, Pochin?
Okay, so here's my computation for the question, but I'm stuck because the result I calculated is 0.
Ah. Okay. I I don't think that's particularly difficult for you, but maybe just uh, some order you get it wrong in some order. That's so I will do that. Wait a
Okay.
minute. Mm, okay. Wait a minute. Sorry.
Okay.
Uh, I want to share. Jesus Christ. Can you guys see my slide?
Yeah, I can say that.
Okay, good. Ah, so the question is integral of x y dv on with theta hedron that is 0 0 0. This one 0 0 1. Y z x0 y1 0 1 0 0 0 0 0 0 1. Hmm. So if we have xy, it's become 1/3 1. The same with xz 1/3 1. But zy is 1 1. So far so good, right?
Yeah.
Okay, good. Um, so this one is y equals 1 minus 1 over 3 x plus 1. Oh, sorry. 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 Minus 3x plus 1. 0, 1, 3, 0. Okay. This one also the same. C equals minus 3x plus 1. This one. C equals y. Um,
Isn't the
so
third one
yes, yes.
isn't the third one z equals to negative y plus one?
You are right. Minus. Sorry. Minus y plus y. Yes. Now we arrange the integration. Of x, y. I think, I guess the easiest one will be z first. dz. After that, maybe dy and dx. Maybe. I'm just guessing. Or what order do you use? Uh, Pojun.
I'm using dz dx dy.
dz dx dy. Okay, no problem. Just mm, okay. I just follow your your dz dx dy. So z in x. So this one. Sorry, this one. Z in x. C is from uh 0 to minus 3x plus 1, right? dz. Now dx to y. dx to y here. X is from 0 to 1 minus y over 3, right? Now dy, y is from 0 to 1. So far, so good?
Yeah.
Okay, There is no z here, so x, y, z from 0 to minus 3x plus 1 dx dy 0, 0, 1 minus y over 3. I don't think there will be a lot of problem, but let us check. We don't care about this. So we have minus 3x squared y plus xy plus xy dx dy same, which so here the problem, right? Minus x3 y plus half x squared y minus 1 minus y over 3 dy. 'That's not nice, but not a big deal either. One minus over 27 y plus y 3 1 minus y square y over 2 dy. 'Is it here you have problem or before here?
Yeah, it might be here.
Maybe here. Shouldn't be any problem here because, well, it sucks to do this, but I mean that's just computation thing. Oh, oh, I make mistake here. Sorry. Here should be 9 times 2. There is 9 there. Sorry, I forget to put. So it should be 18. I think that's it. I mean, from here you can do the normal integration, right? There is nothing.
Yeah, I think I can do it.
I think it's you just make some computational mistake, nothing more than that.
Okay, thank you.
I think yeah. There is. Do you do understand everything, right?
Yeah,
Okay, no problem then. Don't worry. Any other question?
48.
48. Uh, hmm. Sorry, can you share your screen and so we can, so I can see what you have did. Mm-mm. Mm-mm. Um, can you open your book, page uh 1102 1102?
okay.
I think you just use their transformation and everything will be fine after that.
But I'm not sure about the boundary I got to use in the integrals.
Bec- because you I think you use different transformation there. So here you use your transformation is y squares equal r square sin something square, right?
Yeah,
uh, in the book they use y equals rho sine c and sine theta, so using two different angles.
yeah. But I transform into rho square times sine square phi times sine square theta.
uh, Sorry, can you make it bigger?
Okay,
I
okay.
Okay. Mm-mm. 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 So your question is whether your boundary is correct or not, right?
Yeah, because when I draw on the graphics, you can see uh, the phi angle is not from 0 to pi. They're separated.
Oh. I have intuition that your boundary is correct.
Yeah, but how do I transform these XYZ coordinates into R theta phi coordinates with these numbers? Because I input the parameters of the boundaries here to the grapher.
So, how to say? You in the picture there is a discontinuation, right? So there is no when z equals 0, right?
Yeah, yeah.
Why this can happen?
I know that rho is gonna be 0 to 2, and theta is gonna be 0 to 2 pi, but I don't know the upper boundary of phi.
Okay, I will check. Okay, okay. Can you stop sharing for a moment?
Okay.
I think. Okay, okay. Thank you. Okay. I hope this will answer your question, but I'm not so sure. So let us concentrate in the first integration, okay? The inner one, the minus square root of 4 minus x squared plus y squared. And this one is square root of 4 minus x squared plus y squared. This is 2, this is x, y, z. This is 2. So for the upper part, I think it's clear that what they means to be is this this upper dome. Okay? No, there is no problem there, right?
Yeah.
For the upper part. And for the lower part here, well, it is in the lower dome. The same, exactly the same thing, and in the lower dome. Okay. So I think for now it's clear, right? The our border for the z is the dome,
Yeah.
and for xy is, well, because using this in this kind of integration. So only this part. right? Only the right part. The left part is not included.
Yeah,
Do you understand why, right?
yeah, yeah, yeah.
So it is just half of this thing. So this upper part and this lower part, is it the same or it's different from the your graphic? It's different, right?
Yeah, I made a mistake there, but I corrected, so it's the same.
It's the same, right?
Yeah, yeah, yeah.
So do you get how I get this picture?
No.
Okay. So do, you understand our first picture, right?
Yeah, yeah, yeah.
Okay. From this kind of integration. Now, because I know from this picture that the x must be positive here because of this integration, so I cut this half. When I cut this half, I get our final our final picture.
Yeah,
I cut in the y-axis. So we get only x positive. When x negative, it's not our domain. Is it clear?
yeah,
Or hello?
yeah. I understand it.
You understand? Okay,
Yeah, yeah.
good. No, uh, sorry, I I do not watch yet yesterday class. So the material is until when for the exam?
Uh, the assignment, the deadline of the assignment is, I think, Sunday.
Sunday. Oh, so so all of the until 15.9. Okay, good. I think I will. Uh, when will your exam?
Next Saturday.
Oh, next Saturday.
Yeah, yeah, yeah.
Okay, good. Uh, so I think for me, I think I will make the deadline will be next until next Friday. So it's not a big problem to you. Okay. Do you understand the last chapter? The change of integration, change of variable in the multiple integrals. Do you
Yeah,
guys understand?
yeah.
Okay. So no problem there.
No.
No. Good. Hmm. Uh, look, I think Pochin, your last question is giving me some idea. Basically, something like this. Luckily, in the exam, you don't have computer, right? So, and I'm not sure how much time. I forget. You will have because it is online exam. But I mean, I think the time is limited. So be confident, okay? Because I think there is nothing hard in this chapter. So just be confident and be careful and be confident. Make sure every step is correct, and I think everything will be fine. That's just make sure every step is correct, and how to say, uh, if I see the example that you asked, I mean that Professor Iman gave, I think uh, this exam wouldn't be hard, but it will be complicated. Do you understand what I mean, right?
Yeah, yeah, yeah.
Yeah.
So it's, oh, by the way, the question that I asked you, do you guys, yeah, I mean, do you have a problem with that question or not?
You mean which one?
The one that I upload, do you have in the,
No,
do
no,
you-
no, no.
everything is easy, right?
Yeah, yeah, yeah.
Okay, no problem then. Because that's, I think my question more to the conceptual one, but uh, if I if I see what Professor Iman gave in the exercise, I think there will be more about uh, more computation than conceptual. So, well, it doesn't mean that you don't need concept, but well, you must practice accordingly, right? Hmm. So the exam is from chapter 12, right?
Yeah.
So let me uh how to say, briefly 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 remind you, in the chapter 12, the hardest part is cross product. Okay, I mean dot product is easy. The the but the cross product will be very important because, okay, the question is usually something follow this line, following this line. Can you see my slide? Hello?
It's
Yes, okay. Okay.
small. Can you?
The the question will be about, maybe you given a dot or you given a function that intersect another function, a dot or a vector, then your, sorry, yeah, a dot and a vector or some function, and you should make a parameterized equation. So in the equation, usually there is two form. That is, if you have a vector and a dot, then what you have is A, B, C dot product with, sorry, oh, sorry. My point is, in the chapter 12, the hardest part is cross product. You must learn, you must understand what cross product is, and you must understand how to get a vector to get so you can cross it. So for example, if I have a plan and I have three dots, do you understand how I get the equation of this plane? Do you guys understand how? Any idea?
Just product the two vectors.
Yes. So if we have 3 points here, you make two vectors by subtracting this dot with this dot and this dot with this dot, and after that you cross product and you have one point and one vector, and you get the equation. There is a lot of variation of this kind of question, but basically that's the hardest part of chapter 13. Chapter 12, I think. And the other is, you of course you must remember what is ellipsoid, what is elliptic paraboloid, and yeah, all this term. So because there will be in the exam, I think. Chapter 13, I don't think anything's difficult there. Do you agree? I mean, that's it. Chapter 13. Chapter 14. Chapter 14 is actually relatively easy as long as you understand what is partial derivative, what is minimal maximal value, basically when partial derivative equal to 0. The same as one variable, but this you change it with partial derivative. Nothing fancy. Sorry, it's more fancy, but basically the same things. And tangent line, tangent plane. You must master the tangent plane. It is basically linear approximation, but in the three-dimensional. And Lagrangian, Lagrange multiplier. But that's basically the minimal value will be if Lagrange multiplier equal to 0. So you must, I think Lagrange multiplier is not hard, but if you have some, if you want to ask to me about that, you can ask me now, because I think. And chapter 15, I think it seems that for everybody chapter 15 is relatively easy. I mean, it is complicated, yes, but not hard. Do you agree? I think so, right? Yep. Okay. Is there anything you want to ask? because it is.
So I would like to confirm the question I just asked, 48. I want to make sure the boundary of rho, theta, and phi.
The same number, right?
Yeah.
Uh, Sorry, to be honest, I'm a little bit forget about what is which one is theta and which one is phi. But okay,
Theta is from 0 to 2 pi, and phi is from 0 to pi.
yeah. Theta is from 0 to pi, and phi is from 0 to 5. Good. Here, the phi is from 0 to 5, and the theta is also from. I think the theta here is from -phi to phi. Am I correct?
Well, I'm not really sure about it.
Can you share your graphic?
Okay.
Hmm. Oh, interesting. What is the yellow means here?
The x equals to square root of 4 minus y squared.
Ah, I see what's your confusion here, because the picture is not that. I mean, the picture here is confusing. Can you make it bigger? Sorry. Ah. Good. Mm. You know what? The problem is not on the problems, but the problem is on the software that you use. Let me explain. Do you know why there is white in the bottom and there is red in above and they don't touch each other, right?
Yeah.
Well, why they don't touch each other?
Because the one's positive, the one's negative.
Actually, no. They don't touch each other in this, so you can see the whole picture. Actually, they touch each other. In
Oh,
reality, they touch each other.
okay.
So they give you the space so you can see what the shape of each of the boundary, but it make you confused because the the real boundary is the one that I draw to you. It's actually the same, but they want to make it more clear to you, but it confuse you. So look, look, ah look, Do you see that there is like something not in the red and white? There is some like tooth, so it is not smooth, right?
Yeah.
Do you know why?
No.
Well, that's just the graphic. Actually, it's smooth. In real life, it is dome, a smooth dome. So 我觉得比较奇怪啦，那个大多数人是这样，but it just the graphic just confuse you. So if you use another software, then I think it will solve your confusion. So don't how to say software is basically just some person pro- program it according to her or his theory and show it to you. But uh, her or his choice of what to show and what to not to show is maybe clear for her or for him, but it's maybe not clear for us. So I think you just don't 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 let yourself confuse with the graphic. Do you understand what I mean?
Yeah, I understand.
Because so
So
it's
so according to what you said, so rho is gonna be 0 to 2, right? And theta is gonna be 0 to 2 pi because you say two domes are connected uh, together. Actually, they're not separated. But what about the third one, the phi?
okay. So as I said to you before, uh, the they only work when x is positive, right?
Yeah,
And our rule is uh, the integration is counterclockwise, right?
yeah.
So if it is positive and it is counterclockwise, let me. Hopefully the PowerPoint will be okay. Wait. Where is ink, 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 ink? Do you remember where is the ink? Hey, I forget. Sorry. Ink. Sign? No. Insert. La, 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 la. Oh, look. We have x and y, right? And we only want when x is positive. Okay?
Yeah, yeah, yeah.
So here you can see that it is, okay, I'm sorry. It is from minus phi over 2 to phi over 2. So the what the theta, right? Yes, theta is from uh minus phi over 2 to phi over 2. So sorry, I make mistake from before when say from minus phi to phi. What I mean is from minus phi over 2 to phi over 2. Minus 90 degree to 90 degree. Is it clear? No.
Can I say it's from 0 to 180 degree?
No. Because if you say 0 and to 180 degree, it is when y is positive. Well, in this question, it's the y can be negative, right? Because you see that y can is from minus 2 to 2. Do you see the question?
Yeah.
So y in this in the number 48, y can be negative while x must be positive. So if from 0 to 180, it's not the same thing as minus phi minus 90 degree to 90 degree here. Do you get it?
Yeah.
Okay, so it's not the same. It's not even the same to say from 90 degree to minus 90 degree. When I say from 90 degree to minus 90 degree, it's mean when x is negative. Okay,
Okay.
so uh, please be careful about this thing. If the small details, because it's the one that make it or break it in your exam. Okay,
Okay.
is there any question, other question than that?
What I remember the theta, the boundary of theta, is from 0 to 2 pi, and phi is from 0 to pi. It can't be negative in the spherical coordinate system.
Yes, the phi cannot be negative, right?
Yeah.
But the theta can be negative, right?
No. They're from 0 to 2 pi.
Or the theta. The theta is from 0 to phi. Yes, but well, if you want, you can say that negative phi over 2 is what? 3 over 2 phi, right?
Yeah.
So, yeah, you can say that it is from 3 over 2 phi to phi over 2, for example.
So
But,
the lower boundary is gonna be 3 pi over 2, right?
huh?
The lower boundary of the integration is gonna be 3 pi over 2.
Yes,
Okay, thank you.
if you want, but I don't see why it is. That's I mean it's the same thing, so you don't need to make your life difficult, I guess. I mean, do you understand why the theta cannot be negative? Is because we want to limit this to this one side. So if you want to that other part, you must rotate the theta. That's why phi we limit from 0 to 5.
Yeah, I understand it.
Well, that's can we say that the phi from 0 to phi, while the theta is from 0 to 5? Well, you can, but that's not what people usually use. So I mean, it's like, well, coordinate is basically just like language in mathematics. So use what people usually use. Okay.
Okay.
Any other question? If not, I think uh, enough for today. Um, is it is it okay for everybody? So I end it here. But if you want to ask something, you can ask in the discussion group. That's why I open in the discussion forum. What Professor Iman said, I think no. So if I I yeah, I think there is no class for next week. But well, it's depend on you guys. I have no problem if there is class or there is no class. So if you want to have class next week, it's okay. Otherwise, it's also okay for me. So you can you can it's up to you. If you want the class, just say in the forum. Just let me know or send me email. Okay. So I will end it here. Soon I will open the Moodle so you can upload the the one that the problem that I give to you, and good luck for your uh, exam. Thank you guys. See, see you when see you. Welcome. See you.